kinds of variables, right? And we're going to break it down into a little bit further a little later in the course. The textbook mentions transforming numeric and categorical variables. This can be a little tricky, so let's have a look at it. Most of you probably know that if you want to transform a quantitative variable into a categorical variable, all you need to do is kind of group the values, right? So let's say I did a survey and I'm looking at how many fish people caught during fishing season. I might decide that anything below 4 fish is just a little, right? I'm going to group 1, 2, 3, 4 as a little, or a few, right? And I might decide that anything above 12 fish is a lot, so, 13, 14, 15, anything, is a lot. And then in between I'll just call that average, right? So one thing you might notice in transforming the value from like a numeric to a categorical variable is that we've actually lost some information from the variable. I used to have a number of responses that ranged from 0 to, let's say, 23, right? Somebody caught like 23 fish. Now I just have 4 response categories, which is none, a few, average, and a lot, right? So I've actually kind of lost information from the way that I'm, from the data. And so that's okay. But here's where it gets problematic, right? Let's say I wanted to go the other way, right? I've sent out my survey and I've asked people, have you caught 0 fish, a few fish, average amount of fish, or a lot of fish, right? And people have responded back and however many they've caught. It's not possible for me from that information to figure out specifically how many fish each person has caught, right? Because a few fish could be anything from 1 to 4, right? I'm not sure where each person has said, like, is it 1? Is it 3? Right? It's just a few, right? So it's possible to reduce information, to go from a continuous variable to a categorical variable. It's not possible to produce information from nothing, right? It's not possible to switch from a categorical variable back to a continuous variable. It doesn't work that way. Where it gets tricky is that the textbook says that you kind of can transform categorical into quantitative or continuous variables. It's not really the same as the other transformation. What they say is that you can just assign numbers to the categories. So, like if I had none, then I might assign a 0 to that, and if I had a little, then I might assign 1 to that. This process is called dummy coding, right? It's really useful for doing like data entry. That's very helpful, but we need to be very careful about how we treat that data. The thing to remember there is that these numbers that we've assigned don't actually have any mathematical value. Right? What they are symbols for the categories. So let's say we take a question about religion, for example. Logically, it's a categorical variable. You have, Christians and Hindus and Buddhists and Muslims and atheists, right? And we can demicode those. We can say 1 equals Christian, 2 equals Hindu, 3 equals Buddhist, 4 equals Muslim, and 5 equals atheist. But when we start to do analysis on our data, right, we can't say that 1 Muslim is equal to 2 Hindus, right? The same way that we would say 2 times 2 is 4. Or that a Christian and a Muslim, if we add them together, are equivalent to an atheist, like we would say 4 plus 1 equals 5. That doesn't make any sense and would probably offend quite a few people, so we're not going to do that, right? Unfortunately, you see this problem come up a lot in research that uses Likert scales, If you have extreme disagreement, then you select 1, and if you have extreme agreement, you select 5, and if you're neutral, you're 3, right? You've seen these before. Well, one person's strongly agree is not necessarily equal to another person's strongly agree, the way that 5 is equal to 5 all the time, right? They're not mathematically congruent. So these scales can be analyzed appropriately, but you need to have a lot of caution, especially if you see one in a research study. You should ask yourself, like, are the researchers actually treating the numbers appropriately? Okay, so next up we have correlation and causation. One of the mantras that you should be repeating to yourself, like basically every night before you go to bed and every morning when you wake up, is correlation does not equal causation. Correlation does not equal causation. Correlation does not equal causation. Okay? Just because you see a relationship between a couple of variables doesn't mean that one caused the other. There are three criteria that are needed to determine causation. First of all, you need a systematic variance of the dependent variable with changes in the independent variable, right? You need to see that when one changes, the other also changes, and it does so in a regular way, right? Secondly, you need temporal precedence of the independent variable before the dependent variable. You need to see that the independent variable comes first, right, before the dependent variable changes. If it's the other way around, right, then you don't have temporal precedence. You're not sure which is causing which. And then third, right, is that there's a lack of plausible, explanations that are alternate to causation, right? And this includes chance, right, that things are just happening randomly through chance. Now, a correlational study will address the first point, that there is a relationship that happens. There's systematic variance of the independent variable and the dependent variable. But sometimes it's not very good at addressing the second, that temporal precedence. You can't tell which one comes first, is it chicken or egg, right? And then it usually fails to address the third about the lack of plausible alternate explanations because there's not a lot of control in a correlational study, right? There are other variables that might come in there and better explain it or at least equally explain it. The book notes that there's a strength between correlations. It's usually expressed as the letter R. And that ranges from 0, which is like there's no relationship, to 1, which is there's a perfect relationship. Positive correlation means that the values follow the same direction. As IV rises, so does the DV. And the negative correlation indicates an opposite direction. So as IV rises, the DV actually falls, the direct variable, the dependent variable falls. Alright, so before we finish the chapter, let's just really, really briefly touch on qualitative research. We're going to come back to it in a lot more depth later on. But in my experience, students are mostly familiar with quantitative research, like the scientific method and everything. In many cases, that's probably how a lot of you think about research. In general, that's your paradigm right now. The idea of qualitative research probably a little bit hazy for a lot of you at this point. But as I said, at the beginning of this chapter, it's important to approach each paradigm on its own terms. And so we've been talking about quantitative research right now, and the best thing to do is kind of put that out of your mind or compartmentalize it when you start thinking about qualitative research, because it's very different. This is not quantitative research. When you start thinking about quantitative research, probably the best place to start actually would be you might try watching some of these documentaries. I'm going to post a list of documentaries here. Of course, not every documentary can be considered qualitative research. Of course, there are some differences between the rigor of most academic qualitative work and the values that sort of drive a commercial film that's being shown for audiences for a profit. So you should be aware of those as well. They're not always designed necessarily to provide dependable knowledge that we can rely on necessarily as to bring in box office earning. But that said, these movies may be a good place to start in thinking about qualitative research. So, what is qualitative research? Well, at the heart of it, we're looking for subjective lived experiences of participants. We're interested in how they perceive and understand the world, how they make meaning or make sense of everything, and the processes that they use to negotiate challenges in their lives, and the stories that they have to tell about that. There are three primary means of collecting data in qualitative research. Primarily, you have interviews, observations, and documents or other artifacts that might also provide you with information such as letters or reports or pictures or movies, or videos, music, receipts, so on. On the other hand, even though there's just sort of a few ways that data is collected, there are many, many, many ways of doing sort of analysis on that data. You can come from a number of different perspectives and do a lot of different creative stuff with it. So there are 5 approaches that are described by the text. There are more than 5 approaches in qualitative research, but these are kind of the main big ones. Phenomenology examines the essence of the experience of a phenomenon. What is this phenomenon about? What makes it? Ethnography is a study of cultures. We don't necessarily study, culture so much as like subculture. So, the subculture of a school or maybe the subculture of a particular group of society. Those seem to be more interesting to modern ethnographers. Narrative inquiry assumes that people's lives are storied and investigates how those stories are constructed and how they function socially. Case study involves sort of a specific or bounded system for studying, so something that's like a specific person or place or like an organization or an event. Those are all cases that can be studied. To give you kind of a contrast, phenomenology is more of a general examination of an experience. So they're a little bit different. Grounded theory is used to generate what they call low-level theories, basically just explaining what's happening in a process or a phenomenon. These can often stand alone as their own findings. Sometimes they're used to inform quantitative studies. They become hypotheses that can be tested. So that's a really, really, really brief overview of like the big 3 methodologies: quantitative, qualitative, mixed methods. And we're going to come back to each of these, and we're going to get really, really in depth with both of those. And so if there's something that's maybe not making sense right now or sort of a little bit ambiguous for you right now, it'll probably be clarified throughout the course, a little bit later. So stay tuned. All right.